Another very basic rudimentary way to communicate between processes is to use signals. You can see signals as events pretty much. So we are going to look at a very basic program which is going to illustrate both the kill, the sig action, and the way to actually send yourself a signal with alarm to pretty much notify your process after a certain duration of time. So our program is very simple. When you run it, you are going to see just like the same message coming on the screen every 5 seconds or something like that. What we want to do is to have a signal handler function, let's call it ADER, okay, for the sig alarm signal, and we are going to use sig action to register in our process the ADER function as a handler for the sig alarm signal. And then we are going to ask with the alarm system call, we are going to ask the kernel to send us a sig alarm signal in 5 seconds. Once this happens, once we are done with setting up the stage there, we're going to enter an infinite loop. And 5 seconds later, our ADER function will be called. This ADER function will display a message on the screen, ADER, why not? And is going to ask again the kernel to send us an alarm in 5 seconds. So this is a very basic program, just there to illustrate what you can do with signal. Okay, very basic signal processing. So there we are. We have the boilerplate code. Don't forget to include signal.h. Okay, what do we need to do in the ADER function? That's our signal handler. So I'm following the basic prototype that is given in the reading assignment. Okay, it's a void function that takes one parameter, which is the signal number. I'm going to display on the screen ADER \n, and I'm going to set an alarm in 5 seconds. So the alarm system call as a kernel to send you a sig alarm signal in 5 seconds. I'm going to do that every time ADER is invoked, which means every time I receive sig alarm. So before to go there, I need a structure sig action, which I'm going to call SA. The mem set that is done on the structure is just a relatively dirty way to just set every field in that structure to 0. What you say indeed here is set to 0 the memory starting at address of the variable SA, and set as many 0 as size of SA, which effectively put every field in the structure to 0 by setting every single bit of the structure field to 0. We do that because there is really only one field that we are going to manipulate in this course. This is a SA_handler field. This field takes a function, the address of a function as value, which allows us to say this is a function I want you to call when you receive a specific signal. And you specify which signal you're talking about when you are calling the system call sig action. Sig action says when I receive this signal, and you use here one of the code that correspond to a specific signal, I want you to do whatever I describe in this data structure, and in this case that means pretty much look at the SA handler field, and this is the only thing we specified. So when you receive sig alarm, call ADER, and I don't care about getting from this system call the current disposition of the signal sig alarm. That would be the role of the third parameter. Once I'm done with that, hey, wake me up in 5 seconds. In between, I'm going to do absolutely nothing. Okay, what's important to understand is that this process will execute the code here, which is nothing, repetitively. And asynchronously, once in a while, it's going to receive a signal sig alarm and stop doing whatever it was doing, which is just looping through this infinite loop, to execute this code. And then as soon as this code is done, we go back to where we were in that loop, okay, and resume execution exactly where we stopped it. So it's really kind of an interruption of the regular processing of the code. Don't be fooled, we don't do anything useful here in the code while waiting for the signal, but we could. That would be like the case for most actually program using signals. So let's open Conqueror and let's give a little compilation to this code. Syntax is okay. Let's try to run it. First message. 5 seconds, second message. 5 seconds again, third message. It looks like it's working. Control C to stop the parent process. And I'm going to put back the code on the screen so that you can see it.